This is the Unit 4 test review. The first question asks, if the ordered pair x6 is a solution to 4x plus y equals 26, determine the value of x. So we just need to take the y value that is given, which is 6, and we need to plug it in. So 4x plus 6 equals 26, and when we solve, x would equal 5. For 2a, the slope of a horizontal line, hopefully you remember HOI. That stands for a horizontal line has 0 slope, and the equation starts with a y. So slope of a horizontal line is 0, and the equation of the line shown, you just have to find that y value that it goes through, and it is y equals 5. For b, slope of a vertical line, I think of Vux. So I know the slope of a vertical line has undefined slope. And the equation of the line, if I go over here, it is going through the value on the x-axis of 4. So it would be x equals 4. Number 3, if we need to know the slope and the y-intercept of an equation, the best form to get it in is slope-intercept. So you just have to solve for y. So y equals negative 2/3 x plus 2. So the slope is negative 2/3. And the y-intercept is 2. 4, which of the following describes the line containing the points 0, 4, and 3, negative 2. There are several ways you can do this problem. First thing I would do is, since the ordered pair 0, 4 is given, and that is my y-intercept, and all of my answer choices are in slope-intercept form, I would mark out any answers that did not have a y-intercept of 4. So that would be D and B. Then second thing I have to decide is I can either find the slope of those 2 points, and that looks like it's probably going to be pretty easy. So if I find the slope, I would have negative 2 minus 4 over 3 minus 0, so negative 6 over 3, so the slope would be negative 2, so my answer would be A. You could also put those last 2 choices left into your y equals and check your table to see which equation had those 2 points listed in the table. Number 5, if we are going to graph, it always needs to be in slope-intercept form. This question was nice enough to say using slope-intercept form, but you could also use your x and y-intercepts if you wanted to, but I like to get it in slope-intercept form. So by minus 4x remember, you can always pause the video so that you can do the work first, and then you can watch to make sure that you did it correctly. So we have y equals 2x minus 4. So I would start at negative 4 and go up to right 1. Or down to left 1. And so there's the graph of our line. Over here, I've got to do the same thing. So we've got y equals, don't let this part fool you. Negative over negative is a positive, and remember there's an understood 1. So that's going to be 1/2 x minus 3/2. And you're just going to have to estimate the 3/2. That's negative 1 and 1/2. So I'm going to estimate it there. Then I'm going to go up 1, right 2. I like to go all the way across so that I have a nice line. And so there's my line. 6, write an equation in slope-intercept form with a slope of 3/4 and a y-intercept of -1. In this case, since you're given your slope and your y-intercept, you can plug straight into y equals mx plus b. So y equals 3/4 x minus 1 would be your answer. Write an equation in slope-intercept form of the line shown. So if you can get your slope and your y-intercept, you can plug straight in. So if you have a graph, it's easier to count your slope, and you don't have to use the points that are given, because notice, I could use any of those points, but I'm going to go down 1, right 1, down 1, right 1. So my slope is -1. My y-intercept, let's see if we can find that, is -1. So now I'm just going to plug right into the formula. Y equals -1x minus 1, and you do not have to write that -1, or the 1 part. You have to write -x minus 1. 8, we're writing an equation in slope-intercept form of the line that passes through the given point and has the given slope. Well, since they did not give me my y-intercept, I'm going to have to use point-slope form. And most of the time, point-slope form is the form that you will start with. So I'm going to plug in, and remember, you can use your chart, and this formula is on there. Y minus, my y coordinate is -4, equals -1, that's my slope, and then parentheses x minus 3. Then if you want to go to slope-intercept form, all you have to do is solve for y. So I'm going to go ahead and change that to a plus. I'm going to distribute my -1, so y plus 4 equals -1x plus 3. We subtract 4. Y equals -x minus 1. Now we're going to write an equation in slope-intercept form again. It's a very popular form of an equation, with a line that has a slope of 1/2 and an x-intercept of 6. Now this one is tricky, because don't think that you're given your y-intercept, because that is your x-intercept, but you can easily write a point from your x-intercept, 6, 0, and then use point-slope form. So y minus 0 equals 1/2 times x minus 6. Then we distribute the 0, you don't have to worry about. Y equals 1/2 x minus 3. Okay, number 10, write an equation for a linear function f that has the given values in slope-intercept form. Well, function notation, you can easily write ordered pairs. So that needs to be the first thing that you do, because we have to have ordered pairs to find the first thing, and that would be the slope. So when I find the slope, that's -1 minus 2 over -2 minus -3. Watch those negatives. So that's -3 over 1. So we have a slope of -3. Then you have to choose your point. And you can choose either point, and you would end up with the same equation in slope-intercept form. So you choose whichever point you want. I'm going to choose the one with only one negative. So when I start my equation, it's y minus 2 equals -3 times x minus -3. So you should get y equals -3x minus 7. 11, write the equation in slope-intercept form that passes through those 3 points. Now the tricky part here is that you only need 2 of those points, so you just have to pick 2. Please don't let it throw you off that there are 3 points. I'm going to pick the 2 points without negatives. I like to work with positive numbers. So first thing I'm going to do is find my slope. So that is 10 minus 7 over 4 minus 1. So that is 3 over, sorry, I put a 1 instead of a 3, 4 minus 3, okay? So 3 over 1, so our slope is 3. Then you can pick which one to use. I'm just going to pick this one because it's smaller number, so 3, 7. So y minus 7 equals 3 times x minus 3. So y minus 7 equals 3x minus 9. Y equals 3x minus 2. Now number 12, because is also very similar to number 11, but write the equation of the line passing through the points 7, 1, 7, negative 4, and 7, 4. Hopefully you realize that every x value is 7, because this is going to be a vertical line, so your equation would just be x equals 7. If you did not notice that, you should definitely notice it if you were to calculate the slope. So I'm going to calculate the slope using those two. So I would have 4 minus 1 over 7 minus 7, 3 over 0. Anytime you have a 0 in the bottom, it is undefined, which should lead you to your word vux, which tells you that it is a vertical line passing through 7 on the x-axis. Okay, number 3, the table shows the price per DVD for different quantities of DVDs. Does the relationship represent a linear function? So you just have to see if there's a constant rate of change. Well, I can see that the number of DVDs going up are going up by 1, so that is constant. And I can tell the price per DVD is going down by $2 every time. So yes, this would be linear. Now we need to write an equation that models the price per DVD as a function of the number of DVDs purchased. Well, now that you know how to do linear regression, you have a couple of options. You are welcome to pick 2 points and find the slope and plug into slope-intercept form, or you can use your calculator. So I think I'm going to use the calculator just to kind of get us warmed up before we do some of the ones that we have to use our calculator for. Okay, so first thing I'm going to do is I'm going to go and put in my data by pressing Stat, then Edit. I'm going to clear out what's in there by highlighting L2, hitting clear and arrowing down. So I highlight L1, I press the clear button, and I arrow down. So I need to put 1, 2, 3, 4, 5, 6 in L1. Then I need to put in the price. So after this problem, I will pause the video to put in my data to save time, so you will need to do the same. Okay, so once I have my data in, I double check to see that my lists are even, and they are. So now I hit Stat, arrow to the right, number 4 is linear regression. So I'm going to press 4. I'm going to go ahead and store the regression equation, so alpha trace in y1, and then I'm going to calculate. And so my equation would be y equals negative 2x plus 22. Remember, you are welcome to do that by hand as well. So now we're going to write an equation in point slope form with the given point and the given slope. Well, point slope form is the one we usually have to start in, so this is just less work for us. So we have y minus negative 7 equals negative 1/2 times x minus negative 4. The only thing you really need to clean up about this is the double negatives. So I'm going to change those, and then I'm going to rewrite. Y plus 7 equals negative 1/2 times x plus 4. And you're done. 15, write an equation in slope-intercept form of the line that passes through those 2 points. So we're going to have to first find the slope. So that's going to be m equals 5 minus negative 4 over 2 minus negative 4. So that is 9 over 6, which reduces to 3/2. Remember, leave your slopes as fractions. Now we're going to plug into point slope form because that's what you have to work with. So I've got y minus 5 equals 3 over 2 times x minus 2 going to distribute y minus 5 equals 3/2 x minus 3. So finally, y equals 3/2 x plus 2. Now we're going to graph number 16. Once again, I like to put it in slope-intercept form. You're also welcome to use your x and y intercepts. So I'm going to distribute so y equals 2/3 x plus 4. So I am now going to graph starting at 4 on the y-axis. And I need to go up to right 3, but I don't have any option to go up to right 3. So I'm going to go down 2, left 3. Down 2, and I can't go any further. So I'm going to draw my line. Okay, 17, we need to go to standard form. So standard form, there's two rules. You can't have any fractions and you can't have a negative in the front. Once it's in the form ax plus by equals c. So that's what standard form looks like. So the first thing we need to do is we need to get the x term out front. So if we minus 1/5 x, we are working with negative 1/5 x. Oh, and actually I made a correction. This is actually supposed to be, and I apologize. This is supposed to be over 10. So I'm going to rewrite the problem that we're working with, because on your review, that's what it is, and I don't want to confuse you. So I'm actually starting with the equation y equals 1/5 x minus 3/10. So now, you still start out the same way. I've still got to minus this 1/5 x. And I have negative 1/5 x plus y equals negative 3/10. Now I have a fraction and I have a negative in front, and I'm going to get rid of both of those at the same time. When you have two fractions, you want to think about what the common denominator would be, and that would be 10 for 5 and 10. So I'm going to multiply every term by negative 10. So up here, if we cross reduce, that would cross reduce to 2 times x is just 2x. That would be minus 10y equals 3 would be your answer. Okay, we have to write in standard form from the given graph. So I'm going to use my shortcut since I can see the slope and the y-intercept on this graph. So my slope is going to be down 3, right 1. So my slope is negative 3. My y-intercept is negative 5. If you notice that you can do that, great. If not, just plug into point-slope form and you will eventually get to slope-intercept form. So I have y equals negative 3x minus 5. Once it's in this form, your step to go to standard form is going to be the same every time. You've got to move this x term, so negative 3x to the other side, so you're going to plus 3x. So you have 3x plus y equals negative 5. You're not breaking any rules because you don't have any fractions, and the 3 in the front is not negative. 19, we're going to write an equation of the line that passes through the given point and has the given rate of change. Now, the rate of change is just the slope, and we're going to go all the way to standard form. This will probably be one of the longer problems that we do. So I'm going to start out in point-slope form because I don't have my y-intercept. And I'm going to change that double negative to a plus. So from point slope, even though I have to go all the way to standard, I'm going to go through slope intercept first. then I need to plus 5. So now, when I rewrite, I'm finally in slope-intercept form. So y equals 3x plus 29. Now I have to go to standard. And once you're in this form, your next step to go to standard is always to move over your x term. So I'm going to minus 3x on both sides. So negative 3x plus y equals 29. You can't have a negative in the front, so you can either multiply or divide every term by negative 1. And that's going to change all your signs. So 3x minus y equals negative 29 would be your answer in standard form. 20 says write an equation of a line that passes through the point negative 3, negative 2 and has an undefined slope. As soon as I see that word undefined, I think of Vux. So I know my equation is going to start with an x, and I know it's always going to go through this x value in this given point. So my equation would be x equals negative 3. And with Vux, I've also already answered that it is a vertical line. Okay, so 21, write an equation of the line that passes through that point and is parallel to the given equation. So if I want a line that is parallel, I want them to have the same slope. So that means first thing I need to know is what is the slope to this line. So I'm going to have to put that in slope-intercept form so that I know what the slope is. So I know the slope of that line is 4. And since we want parallel, I'm going to use that slope. And I'm going to use that point, and I'm going to write an equation. Remember, if it just says equation, just go to slope-intercept form. You don't need to go any further. So I've got y minus 4 equals negative 4 times x minus negative 1. So now I'm going to distribute and go to slope-intercept form. So y equals negative 4x. And this cancels out to 0, and you don't have to write the 0. Your equation is just negative 4x. 22, which of those lines are parallel perpendicular? And the reason it says to show all work is because you cannot tell unless those equations are in slope-intercept form. So line A is fine. I can easily tell my slope is negative 2. I can't tell in line B, so I would have to get my equation in slope-intercept form. So we would have y equals 1/2 x plus 3 over 2. So my slope of line B is 1/2. Then the slope of the last line, I just need to minus 2x. So y equals negative 2x plus 1. So the slope of that line is negative 2. So if I'm looking, A and C have the same slope but different y-intercepts. So those are going to be parallel. So I could say that A is parallel to C. And if I check the slope for B, I can also see that negative 2 and 1/2 are opposite reciprocal of each other. So I could say that lines A and C are going to be perpendicular to B. On 23, which equation represents a line that intersects y equals negative 1/2 x minus 5 at exactly one point? Well, the only type of lines that don't intersect are parallel lines, which we just reminded ourselves that have same slope. So I'm looking for a slope that is not negative 1/2. Well, that takes out B. It also, if I reduce negative 2 over 4, that reduces to 1/2, so that doesn't work. And same thing for D. So as long as lines have different slopes, then they intersect at one point. And number 24 and 25, You can write this down on your paper. I'm not going to write it. We already talked about parallel lines have same slope, but you also need to remember that they have different y-intercepts. And 25, the most important thing to remember about perpendicular lines are that they have opposite reciprocal slopes. A satellite company charges a monthly fee of $18 for service. To use the service, you must first buy equipment that costs $85. Would the cost of having satellite service be a linear function with respect to time? And the answer would be yes, because this $18 is a monthly fee. So since it has a constant rate of change monthly, then it would be linear. 27, we're going to write an equation of that line that goes through the point -4 to -8 that is perpendicular. So hopefully you're thinking opposite reciprocal whenever you see that, to the line 8x plus 3y equals 7. Well, I can't see the slope in that line, so I'm going to have to make it in slope-intercept form. Okay, so the slope of that line is -8/3, but it's very important that you remember this step, that you must do the opposite sign, so that's a plus, and then you must flip it. That's the reciprocal part. So the slope that I actually need to use is 3/8 for my new equation. So now we can start. So we have y minus -8 equals 3/8 times x minus -4. I'm going to go ahead and change my double negatives to positives. And I'm going to distribute, because I'm going to go all the way to slope-intercept form because it just says equation. So y plus 8 equals 3/8 x plus, that's going to be 12/8, which reduces to 3/2. So now I'm going to minus 8, and I am going to show you a quick trick in the calculator, mainly for time saving. You should be able to do this by hand, but if it will save you a little time on the EOC or your test. So I'm going to plug this in my calculator. So the main thing to remember is that you always have to put your fractions in parentheses. So I'm going to do parentheses 3 divided by 2. Close parentheses, and then I'm going to minus 8. And then I'm going to press enter, and it gives me a decimal, and I would rather have a fraction, so I'm going to hit math, enter, enter, and it tells me that my fraction would be -13/2. So y equals 3/8 x minus 13/2. Remember, you should know how to do it by hand, but that's just a trick on the calculator to save some time. Okay, 28, we have an xy plane. The equation of line L is x plus 3y equals 12. Which of the following is an equation of a line that is perpendicular? Well, we have to know this slope, and you can use that picture, but it's not the best picture. So I'm going to find the slope of this line. So I'm solving for y. Okay, so my slope of that line is -1/3. So if I want the opposite reciprocal of that, I'm looking at a +3. And then if I check my answer choices, the only one that has a +3 is C. For 29, we want an equation of that line shown. And here's the line. It goes through the x-axis at 4. It's a vertical line. So the answer would be C. Hopefully when you see a vertical line, you think of bucks. For 30, a car is expected to decrease in value according to the equation y equals -1500x plus 25,000, where y is the value of the car after x years. And you can write this on your paper. I'm just going to talk through the answer. For A, the meaning of slope, well, that's negative 1,500. That's how much the car decreases in value every year. So the car decreases $1,500 in value every year. The meaning of the y-intercept, the word I like to remember for y-intercept is the initial value or the starting point. So the $25,000 would be the amount the car cost whenever it was purchased. Which equation could be used to generate this table of values? You're welcome to plug these in by hand to each equation, or you can use your calculator, go to y equals. So I'm going to first of all, I'm going to turn off the plots, and then I'm going to plug in negative 2x, and I'm going to graph. Now, if your graph looks weird, like mine does right now, you can always press Zoom 6 to go back to a normal window. And I don't really even need to see this picture. I actually need to look at my table. So, and I'm at 25, so I'm going to change my window, and I'm going to start at negative 1, because that's the first one on my table. And if I look, the first one is 2, then I go to 0, 1. Well, notice on my table, 0 is 0 for A. So that means that that would not be the answer. Now I'm going to do the same thing with B. So I go back to my y equals, I clear it, I put 2x plus 1, I check my table, second graph, and then I check again. Well, this time when I check negative 1, the y value is not 2, so B is not my answer. And I'm almost positive the answer is D, so let's check that one next. So x squared plus 1, and I'm going to look at my table. So negative 1, 2, 0, 1, and then 1, 2, and then 2, 5. So the answer is D. Okay, which graph best represents that function? Y equals negative 1.75x plus 5. I like to eliminate answer choices on a problem like this. I know my y-intercept is 5, so that's the first thing I'm going to do. So that one still works. That one still works. This one does not work, so we can cross off that one. And this one works. Second thing I want to do is check my slopes. My slope is negative, so I know it should be going in this direction. Well, that's a positive slope, so that one doesn't work. And then this is a positive slope, so that one does not work either. So the answer has to be J by process of elimination. If you needed to actually count your slope, you could actually put this negative 1.75 in your calculator and hit math, enter, okay, to get the actual slope if you needed to count it. On 33, without graphing, determine if the line is parallel to the other line that's given. So they have to be in the same form first. So we have y equals 3x plus 5. So if we check, our slopes are the same. Our y-intercepts are different. So yes, they are parallel. Now I need to do the same thing with the second set of lines, but I need to know if they are perpendicular. So I've got to get them in slope-intercept form first. Got to do the same thing over here. So I've got y equals 1/4 x minus 3/8. If we check our slopes, we have a negative 4 and a positive 1/4. So yes, they are perpendicular, and yes, these were parallel on 33. We have two answer choices for 35. Which equation has a graph that's parallel to the graph that's given? Well, I'm going to get it in slope-intercept form. So we have y equals negative 6x minus 1. So I know my slope is negative 6. So now I just need to see which of these two has an a slope of negative 6 as well. Well, if I look at A, so if I minus 6x, I have y equals negative 6x plus 24. Well, that has the same slope. So A is going to be parallel to the equation in my problem. Now for 36, which equation best models the line of best fit for the data in the scatter plot? So this is kind of old school where we're going to kind of estimate our line of best fit, and it's hard for me because of my shadow, but the key is you want to have the same number of points above the line and below the line. So that's pretty good. I have 1, 2, 3, 4 above and 1, 2, 3, 4 below. And now I'm just going to see which one matches. Now from the beginning, I knew that this data had a negative correlation. So I know I can take out anything with a positive slope. So I can take out C and D. So then the only thing left to check is our y-intercept. So I've got a positive one or a negative one, where I can see that the one that goes through positive one is a better fit. On 37, we have a table with a thermostat setting in units called gas marks on a British gas oven and the corresponding temperatures in degrees Celsius. So first we need to perform the linear regression and find the equation of best fit, and then we're going to use that equation to make it a prediction. So I'm going to go to Stat, then I'm going to hit Enter for Edit. I'm going to clear out my list. And now I'm going to pause the video to put in my data. You do the same. Pause the video and put in your data. Okay, now that my data is in, I'm going to do the linear regression. So I stat calc 4. I arrow down at store regression equation, alpha trace, paste the y1 so that it will paste your equation into y1, and then we calculate. And it says round to the thousandth, so we are going to say y equals 13.571x plus 122.143. And it says use your equation to predict the temperature after the setting the gas oven to a gas mark of Okay, sorry about that. I had a phone call. So I think we're going to predict the temperature after setting the oven to a gas mark of 20. So I need to go to x equals 20 on my table. So I'm going to hit second graph. And I'm at -1, and you can easily scroll down to 20, but I'm just going to show you the shortcut to get to 20 quickly. Second window, and I'm going to hit 20, second graph. So 393.571 would be the temperature at a gas mark of 20. For 38, we need to tell whether the data in the table can be modeled by a linear equation. Explain if the equation is linear, then write the equation with slope-intercept form. We can easily tell that it is going up by 1s on your x's and by 2s on the y's. But I'm going to show you, because hopefully you remember we talked about the correlation coefficient in class. And one thing that you can look at is if your correlation coefficient is 1, you know that it is linear. So first thing I have to do is put in my data. So I'm going to pause and put in my data. Okay, now my data is in. So I'm going to stat calc 4. I'm going to store my regression equation just in case I need to make a prediction. And if you look, your R value is 1, so that means that it is linear. And my equation would be y equals 2x minus 3. Okay, table shows, or the table below gives the number of hours a local baseball team spent on batting practice during each week and the number of hits they had in the game for the weekend. So we're going to have to do the exact same thing with different data. So I'm going to pause and put in my data. So I've got to hit Stat, Edit. I'm going to clear my list and pause the video to put in my data. Okay, now my data's in. I'm going to do the linear regression. So stat calc 4. I'm going to store my regression equation. So alpha trace in y1. And our equation is going to be y equals 0.828x plus 1.662. 2. Then it says use your equation to predict the number of hits following a week when 20 hours, so 20 hours, that's an x value, so I'm looking for the y value at x equals 20. I want to know what that y value is, so I go to my table, and I'm already at 20, so it is 18.214. Now, it doesn't really make sense to say that they're going to have 18.214 hits, so your final answer would just be 18 hits. Number 40, we're going to use a graphing calculator again, and we're going to find the correlation coefficient and predict the missing value in the table. And remember, there are several different ways that we can do our years for our numbers. I think I am going to use numbers. So I'm going to let 2001, I'm going to start that. That's going to be my first year. It's going up by ones. So I'm going to put 2, 3, 4, 5, 6, 7, 8. Actually, I need to be careful because I don't need to put 8 in the calculator. When I make my prediction, I'm going to want to know what y equals when x equals 8. So that's what I'm going to have to do. So I'm going to put in my data, stat, edit, clear out my list, and I'm going to pause the video to put in my data. Okay, so now that my data is entered, we're going to do everything that the question asks. Find the equation for the line of best fit. So stat calc 4 and alpha trace, store regression equation, and calculate. So our equation would be y equals 0.465x plus 68.903. Our correlation coefficient is 0.99, which means that this data has a very, very strong correlation. Now, just to remind you, in case you need to look at your data in your calculator to actually see the scatter plot, I'm going to show you. If we hit graph, nothing is going to come up because we have to do a couple of things. If you go to y equals, if you have things in your L1 and L2, you have to turn on your plots. Now when you press graph, still nothing is going to happen until you press zoom 9. Now we should be able to see our data, and you can see that the line is very, very close to our data points, which is why you have such a strong correlation.
For number 41, we need to compare these two to the parent linear function. You do need to remember that that is y equals x, or you may see it written as f of x equals x. The slope and the y-intercept both change it in some way. So for the slope, that's either going to make it steeper or less steep. So if it is less than 1, it's going to make it less steep. Or we could also call that a shrink. And then the -2 is going to make it shift down. And then for B, we have a negative. The negative is going to make it a reflection. Then we look at the 2 separately from the negative. Since 2 is greater than 1, which is the slope of our parent linear function, that is going to make it steeper or a stretch. And then lastly, the +5 means that it is going to shift up 5 units on the y-axis.